Good morning. Welcome to the sixth session of FLEXCON 2020 on active managed buildings and energy performance contracting. I'm Annick Vastiot, Project Manager at Vito, the Flemish Institute for Technological Research, and I'm the coordinator of the Ambience project, and I'm also your moderator for today. On the agenda for today, we have two presentations. First, we have Nilufar Neyestani, who will briefly introduce you into the Ambience project, and then she will focus on the active building energy performance contract concept and business case. And after this, Jef Verbeeck will present you the ABEPEM platform that is currently under development in Ambience, and that should help ESCOs to make the demand response of the value of demand response tangible. Now, before starting the presentations, I would like to remind you that this session is being recorded and that the slides and the recordings will be made available to you after the session. And of course, we welcome your questions, but please do so via the chat. Now, let me introduce to you the first speaker of today, Nilufar Neyestani. Nilufar has a master's degree in electrical engineering, and she received her PhD degree in industrial engineering and management with a thesis on sustainable distribution network planning, considering multi-energy systems and plug-in electrical vehicle parking lots. Now, currently, Nilufar is a senior researcher in the Center for Power and Energy Systems at INESC in Portugal. She's involved in several national and international projects, also Horizon 2020 projects, and her research interests include demand response, electric vehicles, smart grids, energy system planning and optimization, and multi-vector energy systems. In Ambience, she is responsible for the work package developing the active building energy performance concepts and business model. Nilufar, please, the floor is all yours.
Hello, Annick, and good morning, everybody. It's my pleasure to be with you today and present to you our findings in Ambience project. Now I will share my screen with you. Okay. Perfect. Okay. Today I will be presenting to you the active managed buildings and energy performance contracts as a part of our project Ambience, which I'm going to explain to you a bit later in the slides. The content of my presentation today will start with what is energy performance contracting. Then I will give you a brief introduction to the Ambience projects and the activities that we are doing in this project. Then I will I will go a bit deeper to our activities in developing this new concept on active building energy performance contracting and how we are going to include demand response and flexibility in this concept, and what are the changes and the effects of this incorporation when it comes to the business case and the whole value chain of energy performance contracting. And after that, I will describe to you what is the procedure that we are proposing for the implementation of active energy performance contracting, and what are the changes that are expected in comparison to the current procedure for the energy performance contracting. But first, let's start with a polling session on understanding how familiar you are with the concept of energy performance contracting. So please scale yourself from 1, which is the least, and 5, the most, on how familiar you are with the concept of energy performance contracting before this session. I expect you have around 30 seconds to answer. Okay, good. So from the results, we can see that the majority are on the lower side of being familiar with this concept, and that's good. Don't worry. I will explain to you what is energy performance contracting and how we are going to change it. And then let's continue with our second poll. So you could identify which sector of energy systems you are active. So if you are a market aggregator, technical aggregator, you are from ESCOs, general utility providers, or research and development session. Okay, so the majority are from research and development, and then we have technical aggregators and some from the utility providers and ESCOs, which is very good. So let's start our discussion today with the presentation of what is energy performance contracting. So energy performance contracting, or in abbreviation form EPC, is a form of financing for providing enough finances for the capital improvement and the energy upgrades that are required in a building. And through this improved energy efficiency and improved energy performance of the building, there would be some cost savings, and those cost savings will try to repay this investment and the whole part of the project. In these kind of contracts, usually an external organization, which is typically an ESCO, energy service company, will implement these energy saving projects or renewable projects so that the new streams of incomes would come to the building's billing form, and new cost saving aspects could be achieved. Here in this figure, you can see various stakeholders that are involved in energy performance contracting, with the main focus on the ESCOs, because ESCOs will play as an intermediary when it comes to energy performance contracting. You can see that the energy service company will have to deal with the end users and the host customer, where is going to benefit from the buildings, but also have to have interactions with the building sector, for example, the constructions, with the providers, either equipment or finances, and as well as the grid company, where it can offer the excess production, the flexibility, but at the same time it has financial interactions with the grid for billing and other aspects. What is Ambience project? In Ambience project, our vision is to reduce the building emissions throughout Europe with a focus on electrification that is combined by active control. We know that electrification in buildings is one of the main sources of flexibility, especially when it comes to the heating resources and heating requirements and heat pumps. However, when it comes to the building sector, the statistics show that they are very energy inefficient, and the CO2 emission in this sector is very high. So by encouraging the installation of local production, or encouraging the investment in renewable resources, alongside the electrification, which gives us flexibility in order to combine the consumption with this uncertain amount of production, we can achieve both flexibility that we want and the lower CO2 emission that we want. And these two aspects will give us the consciousness to optimize our consumption in a way to understand when to use this consumption and when to use these local resources that we have. So further achieving cost savings and CO2 emission reduction. The goals in Ambience project is to first extend the energy performance contract to include and incorporate demand response value streams by valorizing the flexibility that can be achieved in active buildings. And by active buildings, we mean those buildings that are equipped with meters, sensors, and ICT technology that help us to optimize the usage of already flexible resources such as storage or PV panels that are available in some buildings. After that, we want to make this active building EPC concept applicable to a broader range of buildings. The current status is that mainly energy performance contractings are applied to public buildings or commercial buildings, and there are very rare cases of residential buildings, even though those have single management and single owners such as social housing. So what we want to do is to extend this application to a broader range of buildings, as well as extend it to cluster buildings and try to add the concept of energy community to this aspect. And in order to do so, we are also developing a tool that supports the forecast of demand response value stream by evaluating and estimating the amount of flexibility that can be achieved in the contracting phase, and then supported with the matching measurement and verification methodology for the operational phase in a way to guarantee this added value stream for those that are going to be involved in this project. We are also going to validate this concept and the tool that we are developing in 2 pilot buildings in Portugal and Belgium, involving real buildings and real ESCOs. And finally, we want to engage all relevant actors and stakeholders when it comes to energy performance contracting, when it comes to demand response or flexibility, in order to hear from them and ensure the applicability of our model. And of course, this webinar is one of the methods that we want to do and achieve this goal and hear from you to improve our work. And as I mentioned before, the expected impact of Ambience project is to reduce emission by actively steering the electricity consumption to times when the carbon intensity is low, as well as shifting it to the times that the price is low, so that we could reduce the total energy cost. And by adding this to business case and supporting it with a proper business model, we want to support the investment for accelerating electrification in the building sector and encouraging the investment on the renewable energy resources to achieve that ultimate goal of reducing the CO2 emission and encouraging the flexibility on the demand side and improving the demand response business case as well. We have identified several beneficiaries in this project. One of them, of course, is environment and society, because being our main vision to achieve a reduced CO2 emission, environment and society is going to benefit from that. Consumers, we are giving a main focus on the demand side, and the consumers, what is their preferences, what would be their comfort requirement. So consumers would be one of the main beneficiaries, as well as other more general aspects of achieving a better cost effective aspect in their buildings, having a better, more efficient building. And one of the most important beneficiaries in these projects are energy system stakeholders, DSOs, TSOs, utility providers in general, because not only they can benefit from the investments that are coming to their sector for installation of wind and in general renewable resources, they can also leverage from this flexibility that are being added from demand side, and they can use it for the operation of the system. And of course, ESCOs being the main actor in the energy performance contracting scheme, with an enriched business model and an enriched business case, they can achieve better prospects in their activities. Ambience project started in June 2019 with 8 partners from 4 different countries and from research and commercial sector. We are in Portugal, Spain, Italy, and Belgium, and this project is going to continue until May 2022. It has been funded under European Horizon 2020 calls, and it has a budget of around 2 million euros. So let's start discussing about what is active building energy performance contracting. In order to understand why there is a need for the active building EPC and why there is a need for enriching the current status, we first need to understand what were the barriers for the market uptake of energy performance contracting. Here there is a list of 7 barriers that have been identified in some previous projects that have dedicated their focus to energy performance contracting. And you can see that from these barriers that what it comes out of it is that there is a need in the building sector and there's a need in the energy performance contracting business case for integrating new services with an improved performance on the buildings. And this performance can be on the energy side and the non-energy side. And by non-energy, for example, the comfort of the building users, the security of providing the energy, as well as new value streams to support the engagement of financiers or the investors or even the end users in this new contract. I also encourage you to visit our website and Ambience Vito to see how these barriers have been affecting the energy performance contracting when it comes to the lower energy efficiency of the buildings and the stakeholders. How are they being affected by these barriers, and how active building EPC can improve that. But when these barriers are identified, on the other side, there's a new opportunity that comes with this new dilemma in the building sector. With these new technology that are spreading in the buildings, with new ICT, with new sensoring, with these new measurements, buildings are becoming more digital and become smarter. And what Ambience wants to do is to take benefit from this new status that we are facing in the buildings and provide new approaches and new vision towards the use of the flexibility and the demand consumption. First of all, when the buildings are becoming smarter and we have more metering and measurement devices, we can use and we can encourage active control. We have more data available and we can track the consumption pattern. We can be more innovative when it comes to, for example, machine learning techniques that is very trendy these days. They are only available now because we have more data available from the building sector. And the active management and the active control of the building will also improve the performance and improve the guarantee on an optimized performance of the building. And through this optimized performance, we can reach a more cost-effective approach in the whole building. And I briefly mentioned before that this more digital building, we can track the other non-energy aspects of the building, for example, the comfort, and try to adapt it to the requirements of the building users, as well as providing a measurement and verification methodology that can guarantee these preferences and the performance that is expected from the building, from both the building energy manager or from those flexibility requesters that they want to use the flexibility of the building. So we come to these 2 aspects. We have on one side energy performance contracting, and we have on the other side the demand response. These 2 have 2 different business cases and they have 2 different technologies. But Ambience wants to incorporate these 2 and back up the energy performance business case with the innovation that comes with the demand response. So this intersection between these 2 is where Ambience and active building energy performance is getting emerged. So there are two-sided opportunities when it comes to this. We all know that demand response is very trendy, and there are so many studies that are being dedicated to demand response, but there are still a lack of regulatory support. There is a lack of business support for the demand response implementation and integration. On the other side, energy performance contracting is very promising, but also lacks the impact that is expected from energy performance contracting. Why? Because the demand side is not completely added in a way to be completely guaranteeable to energy performance contracting. So by giving one single EPC model that can consider both of these two aspects, Ambience wants to give a solution to both of these business sides and both of these aspects that deal with the energy consumption on the buildings and on demand side. And for that, we came to a definition for the active building energy performance contracting. And you can see there are some highlights on this definition. First of all, it is a performance-based delivery. We have a focus on guaranteeing the performance. We are going beyond the passive energy measures, which is the current status, and we want to introduce active energy measures. And we want to extend this the basic energy performance contracting to a broader range of buildings with a focus of CO2 emission using electrification and active control. There's also another aspect that we need to consider, which is our proposal is a modular one, and this helps it to be applicable to already existing energy performance contracting, that they can only take the module that are necessary for them, or they can start a whole new active building energy performance contracting on their own. And of course, we are considering an existing building and new buildings to be able to be incorporated in this new definition and concept. Here I have for you a better visualization of what are the changes that active building EPC will cause to the traditional energy performance contracting. Here you can see that there was the client ESCO relation through the performance contract and the loan, and the only factor affecting was the energy efficiency measure. But with the active building EPC, we are adding demand response in this, the procedure of the business interactions between the ESCO and client, which of course will cause new business model, and I will describe that a bit later. And this repayment is not only from cost saving, but also from demand response incentives. So there are three main pillars for this new concept. First of all, extending the energy performance guarantees from energy efficiency to also flexibility related measures, extending it to a broader range of buildings, residential, hospitals, educational centers. And the third one is to extend this scope to a cluster of buildings and adding the local energy communities and adding what could be the business models that could emerge from having these energy communities. Of course, you know that there are a lot of studies that are being dedicated to demand side flexibility, and there are many factors that affect the demand side flexibility, mainly acting as the barrier. But here we want to see how energy performance contracting can help these barriers to become enablers for the demand side flexibility. So there would be a mutual benefit when it comes to incorporating demand side flexibility to the energy performance contracting. Here I have identified 6 main factors that affect the demand side flexibility, but I will go through just 2 of them to show you how energy performance contracting specifically can affect the change of these barriers into enablers. For example, availability of technology is one of the main barriers for achieving demand side flexibility. Energy performance contracting is a financing mechanism where they can provide you the investment that that the building needs for installing, for example, storage devices, for installing metering, for this kind of stuff. So this that automatically changes this barrier into an enabler. Another part is measurement, validation, and settlement when it comes to demand side flexibility and how the end user reacted towards the demand side demand response signals. energy performance contracting on its own has the baseline estimation, flexibility estimation when it comes to active building EPC. So provide solution for this barrier and change it to enabler, so helps the encouragement of demand side flexibility. On the other side, the demand response will also give value to the active building energy performance contracting. I'm pretty sure that you're all familiar with various types of demand response that are in the market, available in markets such as load shedding, load shifting, and more dynamic pricing. And as you can see, as these demand response technologies will grow, the benefits for and the value for the ESCO and for the customer that are involving and using this demand response will also grow. And specifically when it comes to the end customer, by avoiding the higher energy prices and additional revenue streams that it can get from demand response, a better cost reduction can be achieved, as well as having a better understanding of what is the pattern of the consumption on the building, which can open new business opportunities for the building and for the end user and whoever manages that building. So with this aspect, the next point of discussion would be what is the value chain of active building energy performance contracting. Here I have the existing energy service value chain when it comes from the energy, the primary energy, and it goes to a standard energy supplier. And the main activities of ESCOs involve energy supply contracting, ESC, and then energy performance contracting. So where in the energy supply contracting, the focus is more on the supply side and the energy that is being delivered in type of services to the demand side, so the useful energy in megawatt hour. And in the EPC is the cost saving and the energy that has been saved due to the increase of the energy efficiency in buildings. So in the ASC, the focus on the supply side, and the EPC, the focus is on the demand side. And what we want to do is to extend this business model to add active building energy performance contracting and add the demand response and flexibility, specifically flexibility to this business model with the flexible watt hour that has been added due to the installation of new equipment and due to the activation of this new type of active building EPC. So you can see that the whole value chain is being extended because of this new concept. Also here you can see that the interactions between the actors with the active energy services this is more or less what's happening now, that the energy market and you can see on the top row how the money goes, and the bottom row how the flexibility goes. And this is usually the way that the energy market, the aggregator, the ESCO, and the end user are interacting with each other. But what we want to do and what we are doing is to extend this business model in a way that we could incorporate new interactions when it comes to ESCOs and the aggregators. Here you can see that ESCOs, they can have a client, and a client can have multiple buildings, which is one of our focuses, to extend the number of buildings, and we call it as pooling. This is one layer of the aggregation, but what we want to do is to add it to cluster of buildings and multiple number of clients to ESCOs. So another level of aggregation, for example, from client A to client Z will happen, and there would be a customer aggregation. And then these interactions would be through a technical aggregator and a future entity that we can identify it as a market aggregator that will give the flexibility that has been aggregated from the buildings to the market. And what we are envisaging here is that this the ESCO can be considered as the new technical aggregator and have a double role here when it comes to active building EPC. And the financing can happen through both either directly to a client and to the ESCO, as it is the case now. So here I would like to have another polling session to ask you, how do you see the uptake of active building energy performance contracting with this explanation that I've given to you when it comes to your business activity? What is the scale? 1 being the least and 5 being the most. Okay, it's very good that I see that the majority of answers say that the market uptake could be very practical, and this is one of the aspects that we can discuss later in our discussion in the session for the questions and answers. But going back to our presentation, now we want to discuss the implementation of active building energy performance contracting. Here I have for you the procedure of energy performance contracting. It starts with a pre-contracting phase where you identify a potential client, you identify possible financing, and then if you agree on basic requirements, you will go to the contracting phase where you have deeper calculations, agreeing on the contractual terms, really identifying the aggregators and the actors and the services that are required, and finally the implementation of the contract and the constant monitoring and operating of the building. But when it comes to the active building energy performance contracting, what happens is that you have to add the identifying the flexibility options in the pre-contracting phase. You have to quantify this flexibility option in the contracting phase, and then try to measure this flexibility in the operation and the contracting phase. And for that, we have identified these changes through the following slides. First, in the pre-contracting phase, what happened is that we divided into 2 main steps: pre-feasibility and feasibility study. So first, to identify what are the options for the flexibility. Is there any flexibility already available, or it needs a lot of investment? Of course, if there is it needs a lot of investments, then it is not a good or potential case for active building EPC. Then we are going to the contracting phase, which is our main focus, and the presentation from my colleague is going to give you how we are going to do the calculations and the measurements that are required in this phase, because this is the phase that we are going to identify the baseline that the contract is going to be based on that, and we want to estimate the flexibility and then estimate the financial calculations that comes with this estimated flexibility. And finally, for the performance phase, which is a constant and ongoing aspect for operation and monitoring. And what is important here is the measurement and verification of guaranteed measures. Of course, there is a part for this operational phase that needs this optimization for the operation to be in line with what has been estimated in the contracting phase, but there is also a part to somehow verify that this is going as has been planned. I go very briefly through this tailored measurement and verifications for the flexibility, because here you can see that if we have one baseline estimated and then or being forecasted based on the previous behavior of the buildings, then with these new energy efficiency measures we could have a reduced consumption, and this amount that has been saved needs to be associated with the investment that has been implemented through this specific project. And with this, what has been achieved through flexibility and this demand response, and how the whole building is going according to the baseline, is one of the parts that ensures the guarantees that has been signed in the contracting phase. And as the final poll, I would like to ask you to let us know, with these changes that are going to be happening in this energy performance contracting and this increase in the demand response, how do you see the main effect that is going to happen in the building sector? What is the main impact from this new active building EPC? Good. So the results says that an improved business case through demand response is the highest impact that is being expected. And with this, I can conclude my presentations, and I think we can discuss your answers to these polls, and also we can if you have any questions, please feel free, and I would be glad to answer them.
Okay, thank you, Nilufar, for the excellent presentation where you brought us again new insights on the active building energy performance contracting. We have some questions in the chats. I will start with the first one, which I think is more on Ambience in general. So you said that one of the objectives is to allow consumption when the electricity has a low carbon footprint. How can you assess it?
It is through the optimization of the consumption that is part of the baseline creation. That's how we are doing. There's one part that I think I missed, which is with these aspects, what we need to do is to shorten the periods of the monitoring. And with that, we need to have more constant monitoring of what's how our consumption is following the baseline that we require in energy performance contracting. So instead of the current status that we have only like monthly assessment, we will have on a daily based assessment. So when you have daily baseline and daily profile of the consumption that you are giving it to your building energy manager, then you can have a better expectation that your consumption is going to follow or at least being dedicated to, for example, the local renewable generation, or going to be shifted where we know that from the market now we have production from the renewable energy resources. So that's one of the approaches that we have, or everybody can have in this aspect.
Okay, great, thank you. Another question is, how do you quantify demand side flexibility in both the pre-contracting and the performance phase?
Actually, we cannot quantify it in the pre-contracting phase because pre-contracting phase is very general. We mainly have only questionnaires, assessment of the buildings, interviews with the, for example, with the investor, with the tenants, with the owner. So pre-contracting phase is very general phase, but the contracting phase is where actually we start gathering some data. For example, gathering historical data that are available from the building, gathering the bills that they have. And that's where we estimate the flexibility, and the details of it comes in Jeff's presentation, how we are doing this estimation, our mathematical approach. And this will also continue in the contracting phase when we have the actual measurement and we have actual data being monitored from the building.
Okay, thank you. We still have a question, a recent one. Do you measure the DSF potential or actual performance? I'm not sure about DSF potential.
Me neither.
Okay, so perhaps the person that asked the question can clarify that. Demand side flexibility. Okay. So how do you measure the demand side flexibility potential or actual performance?
Okay, when it comes to energy performance contracting, what matters is the performance. So what we do is in the contracting phase, there are certain KPIs identifying this performance are being defined, and we calculate those KPIs. But when it comes to demand side flexibility, what we do is that we develop various scenarios. For example, these scenarios can come, for example, from climate scenarios, from various flexible resources scenarios, load growth scenarios that can give you an estimation on the demand side flexibility for the duration of the project. And for that, what we have to do is to carefully define those KPIs, and that is where the importance of the measurement and verification comes or gets even more highlighted. The term that we usually use is that we have routine and non-routine adjustment factors when it comes to demand side flexibility estimation and or how can I say, verification. For example, given the crisis that we are in, there has been significant changes in the usage in the residential buildings and in the commercial buildings. So if you already had energy performance contracting relying on a certain level of flexibility or certain level of consumption, then you cannot do that. So there is a non-routine adjustment for this verification. But for example, as an example for the routine adjustment, what we have example, we are with our new forecast, we see that we are experiencing a hot winter, for example, where we didn't consider, for example, in our forecasting. So we should adjust our expectations on the flexibility or expectations on the consumption profile. These are the aspects that are mainly seen in the measurement and verification. That's why we call it tailored, because it has to be adjusted with this added demand side flexibility.
Okay. There is one more question on, do you also cover on-site renewables, energy storage assets, or smart charging for electrical vehicles?
Yes, yes.
I think the question is here, sorry.
Tell me. No, please continue.
No, I think the question is here, what do we think of sources of flexibility that can be used in Ambience?
Yes. Yes, and of course, deeper and more detailed explanation follows in Jeff's presentation, where he completely covers all the flexibility resources that we are considering. And just as another aspect to make you more interested is that in our pilot buildings, we also have these local resources. We have energy, electric vehicle charging stations, PV panels, and so on. So not only we consider in our mathematical model, but we are hopefully going to verify that in our pilot cases.
Okay, we have another question, quite interesting, I think. What type of demand response activation mechanism are you considering? And the question is it fully automated, or do you also have a degree of interaction with customers? Or the consumers,
for the
sorry.
for the moment, we are only considering the fully automated one, and that is actually a very interesting question, and that it's a part of the discussion that Jef is going to have. So I think we can discuss it a bit further. But for the moment, we are not focusing much on the behavioral demand response in order to ensure the guarantees that we have to include in the contract. So the level of uncertainty that comes to behavioral demand response and interactions to the end users is not what can be still considered as reliable as to be included in the contract. So for the moment, we are mainly considering what can be offered or can be triggered through an aggregator or through an energy manager or ESCO, whatever, who is going to take this role.
Okay, perfect. Then I think we have one last question. I know there is some coming in. A major barrier to condominium heating electrification that I personally experienced, between brackets, is the lack of institutional promotion of coordination between the flat owners. So installing heat pump in individual flats is essentially unviable due to noise pollution.
Mm-hmm.
So yeah, it's about the coordination between the different owners if you have larger buildings which are owned by different people, I guess.
That is actually a very interesting remark, and this is our next step, where we are developing various schemes and possible options of these business interactions. What I have shown is the general part, but as this question also highlights, a client can own several buildings. A building can own several tenants, and what we are doing as our next step is to develop several schemes when it comes to each of these cases, and how all of these requirements, preferences, and aspects when it comes to the interactions of these stakeholders needs to be incorporated or somehow foreseen in the contract. As part of our activities, we have this analysis on the interactions and the interactions between various stakeholders when it comes to each business case. For example, having a heat pump in a multi-tenant building, or having adding one shared heat pump in a complex of buildings. These are the aspects that hopefully is going to be addressed when we analyze the interactions of the stakeholders and further develop the business case.
Okay, thank you, Nilufar. Also, thank you to all the participants for asking us many questions. It's nice to see that you are interested in the topic. I think we can close this Q&A session now and move on to the next presentation from Jef Verbeeck. Let me just introduce you, Jef. Jef has a master's degree in engineering from the Vrije Universiteit Brussels. He also has obtained a PhD there on measurements and identification methods for synchronous machines. And then he worked for 10 years in different companies, mainly on the topics of mechatronic design, architecture, modeling, and simulation. And he joined Vito, the Flemish Institute for Technological Research, in 2011, where he works in the energy technology unit and works as a researcher on algorithms, modeling, and optimization. His main focus is on the application of demand response and its economic value in industrial applications and buildings. And he was involved in different national and international projects, among which Symbioptima, Industry, Renovates, and currently running Antwerp Circular South and Ambience. Jef, I will give the floor to you now to present the ABFM platform.
Thank you, Annick. Thank you for the nice introduction. I am checking. My screen is still not visible.
I see the begin slide of Ambience. Yes, perfect.
Okay, you can see okay, yeah, I hope it is all right. In the attendee screen, I only see myself and not the screen. Can somebody give me some feedback on that, please?
We see your presentation in presentation mode, so it's perfectly fine,
Okay,
Jef.
good, perfect. There we go. Okay, my presentation is on the ABIPAM platform. The ABIPAM platform, which is basically the calculation part, which helps making contracts for ESCOs, and the subtitle of the presentation is making the value of demand response tangible for ESCOs. I hope by the end of the presentation you have a bit of the feeling that we are capable of doing that. You will see as well that in the presentation a couple of questions you have been asking actually in Nilufar's presentation will become a bit clearer. Good. Then this is the contents of my presentation. First, what is the ABIPAM platform? What are the main building blocks in the ABIPAM platform? One of the building blocks is the energy cost cash flow estimation subtool, which we consider as the core to be able to add demand response to EPC contracts, and we'll go in a bit more in detail into there. Then some examples which I hopefully make it a bit more tangible what we try to achieve with the platform, and some final remarks. Good. ABIPAM. ABIPAM is, in my opinion, still very difficult to pronounce, but it is the acronym standing for Active Building Energy Performance Modeling Platform. And we try to achieve three main things with this platform. The first thing is we are calculating the operational cost savings and performance KPIs when you want to do a certain renovations, and that will be used as a basis for the guarantees which will be later defined in the contract between the ESCO and the final customer. Secondly, it will help you to calculate the financial viability of your renovation, include the standard renovations or renovations which include smart control. And third, it will be used again at the moment that the renovations are done and you are in the performance phase, the performance evaluation phase of your project. A couple of corrections might be needed. The very simple example might be that in the contracting phase of your project, your customer tells you that it is an office space which is manned typically on weekdays from 6 o'clock in the morning till 7, 8 o'clock in the evening. And suddenly during the performance phase, you come to the conclusion that he converted it into a call center which is manned 24/7. So that might have quite an impact on the energy consumption and so on. And in order to tackle that kind of things, we are able to recalculate a number of reference numbers and KPIs in order to see whether we still stick to the contractual agreements or not. We try to do that in an as versatile possible way. We try to do that for multiple stakeholders, multiple kinds of renovations, multiple control strategies for demand response, and multiple demand response cash flows. Multiple stakeholders in this context, what we mean with that is you can imagine that operational cost savings and payback time of a renovation project, yeah, that's quite a bit different for whether you are a tenant in a building or you're a building owner or you're a financial institution. So in the platform, we try to take care that depending on what role you have in a renovation project, that we can still make visible what the operational cost saving and the payback time of your potential project might be. Secondly, we try to cover loads of types of renovations. In principle, you will see later on in the remainder of the presentation, our approach is pretty versatile. But in the project now, we focus on the typical building renovations, going from building shell insulation. Of course, quite a focus, as Nilufar already mentioned, on electrification of the heat system, domestic hot tap water, local renewable energy production, energy storage, electric vehicle charging, and so on. We will be able to do some calculations for very standard control strategies, just simple on-off control of devices, but also the advanced ones we need in the context of demand response. So we support smart control with multiple objectives, whether you want to minimize energy, maximize self-consumption, minimize your cost, and so on. In principle, we try to support that all. And last, we have at this moment quite a focus on indirect demand response schemes. So where we try to motivate customers to change their energy consumption behavior based on some price incentives. Whether these incentives come from variable prices over time or time of use, or differences between injection and offtake tariff, trying to reduce peaks and so on. That's all supported, but there's quite a focus on the indirect demand response scheme in the platform at this moment. And that brings me actually to the first poll. What type of demand response do you think is the most suitable in buildings? Do you think it is rather direct demand response, typically a contractual agreement between the building owner, maybe the ESCO, and an aggregator where he contractually can has the possibility to switch off some devices if the conditions in the grid are asking for it? In their indirect demand response being more incentive price based, do you think both are suitable, or you don't really have an opinion on that one? That's a very clear answer. I see that most people think that both types of demand response are suitable in buildings, a bit more on indirect demand response. So we definitely support the indirect demand response, and we later on try to add the direct demand response as well in our platform. Good. Let me explain you the main building blocks of the ABIPEM platform. The platform is built up by means of a number of subtools. You see them all here on the slide. I'll go over them in a second. Quite important to keep in mind is that the whole platform is rather data-driven. So we start collecting with lots of historical data, very generic historical data. What's the weather like in the area where the building is, but if possible, also very specific data, energy consumption profiles, if possible, 15-minute based. So as detailed as possible, typically information you can get out of a building management system. If that's available, that's the perfect starting point. Secondly, we start with making two configurations in the configuration subtool. We create basically a baseline configuration which tries to describe the building as accurate as possible as it is right now before the configuration, before the renovation. And a second one is the reference configuration, which tries to represent the condition of the building as good as possible after the renovation. So once we have these two configurations, we can start making a building model. I'm going to tell you a bit later on how we do that. We make a simplified building model, which is capable to simulate the thermal dynamic behavior of the building, because that's pretty important for demand response in combination with the heating system of the building. Once you have the two configurations here, you can, in the financial economic calculation subtool, already do your investment cost calculation. You know what the difference is going to be between your baseline and your reference configuration. That allows you to give an idea about the investment cost. And then we are going to calculate the energy cost cash flow operational cost saving, first time for the situations as is right now with that model. It's a kind of verification whether that model is accurate for the current situation of the building. It will be later be used in the performance phase to make adjustments. We do that a second time, so we run the energy cost cash flow tool again in order to calculate the operational cost after the renovations, which ends, so in total we end up with a baseline KPI report and a reference KPI report, which tells you everything about energy consumption, CO2 emissions, operational cost, and so on. That information is also given to the financial economic calculation subtool, and by subtracting the two operational costs, you know your operational cost savings. The financial economic tool then knows the investment costs, know what the operational cost savings are, and can then generate an investment report where all the typical numbers which financial people like net present value, return on investment, and so on are nicely represented. It's also in this part of the tool that we can define the role of who are we looking at in this project. Are we talking about an owner of the building? Or do we look at the return on investment for a financing company, and so on? So that's all configured in the financial economic calculation subtool. Good. Then that's all. What I explained to you here is all during the contracting phase. All the information comes in, which is generated here, is used by the ESCO to get a good feeling about what he can promise to his customer. They make an agreement, they start doing the renovations. After the renovations, you are going to evaluate whether you stick to your promises. And that's the second time that the platform will be used. We are collecting operational data that is given to the guarantee assessment subtool, which does a couple of reruns on the energy cost cash flow estimation subtool in order to make some corrections on the actual KPIs. So we have corrected KPIs, and it's the input for the IP MVP, the IP MVP report, which can be used in the discussion with the customers to evaluate whether the promised results are achieved after the renovation of your building. That gives you the big outline of the tool, and that brings me to the next part where I'm going to dig a bit deeper in the energy cost cash flow estimation subtool. Good. This part, the energy cost cash flow estimation subtool, is based on a multiple collector concept. What we do is start identifying which commodities we all have in the building. Typically, you will have electricity, you will have gas, you will have hot water for your heating, maybe you have cold water for your cooling of your building. Then we start adding commodity consuming devices to that collector system. Typically, there will be some what we call uncontrollable load, all the devices which consume electricity, but you cannot really control from a demand response point of view. You'll have space heating, which uses hot water. You'll have hot tap water. You'll have maybe here the use of cold water to do the space cooling of your building. Then we go to the commodity producing devices. Typically that will be, for example, PV panels on top of your building which will produce electricity and inject into the electricity collector. Then we have commodity converting devices which we add to our model. Typically that can be a gas boiler before renovation, a heat pump after renovation, maybe a CHP if you have a big building where you have an interaction between three commodities. You produce electricity and hot water starting from gas, your air conditioning system, and so on. Then the last group are the commodity storage devices. You can add batteries at the electricity side or buffer tanks on hot and cold water to store these commodities. Of course, your building is not, most buildings are not in island mode. They are typically connected to the outside world. So we allow, of course, interaction with the electricity grid. You'll have to buy gas from the gas grid, most probably, if you have a gas boiler. And there is even the possibility that if you have hot water in your building, that you're connected to a district heating system. So that's the exchange with the outside world. And then we are going to do operational cost couplings to all these commodity flows. Of course, electricity will cost money if you buy it from the grid. Maybe you get a tiny bit of money when you inject in the grid. You'll have to pay for your gas. You'll have to pay for your district heating hot water. And maybe you can even inject a tiny bit in the district heating system when you have excess heat available in your building. Keep in mind, we cannot couple costs to the exchanges to the outside world, but any flow inside the building can have a cost coupling as well. An obvious one, for example, could be here the PV panels. It's perfectly possible in a certain business case that an external investor put the PV panels on top of your building, and that you don't have to pay for the investment, but that you have to pay for the electricity which comes from the PV panels for local use, hopefully at a lower price than buying them from the electricity grid. So that's actually how we built up in a quite generic way, our simulation model. Keep in mind, for example, the collectors I show here, it's just examples. If tomorrow hydrogen gets very hip and we have to do something there, we can perfectly add a hydrogen collector there, or whatever commodity you need in your building can be added in a very flexible way in the simulation tool. Good, that gives us what we call the building and infrastructure simulation model. We make two versions of it, one before renovation and one after renovation, which we will then run a couple of times through the platform. As any model, we have a whole bunch of non-controllable inputs, typically weather data and so on. You cannot control from a demand response point of view, but we have quite a couple of controllable inputs. Typically the heat pump control, buffer charging, discharging, charging of batteries, heating control in the building, that kind of things we can control. That's what we call the controllable inputs. The model will then, based on these inputs and the internal states of the model, generate a whole bunch of outputs, internal temperature in the building and so on. And also keep track of all the commodity usage in our building, where the costs are associated to, so that every time we do a simulation run, we get a clear view on all the commodity usage and cost. Good. The model is reused 3 times in the approach we have in Ambience. The first time is, of course, in the contracting phase in the tool in the sub-tool I just explained to you, to estimate the value which can be achieved for the customer. Second time is that we are going to reuse this model in the operational phase. When we are actually going to control the building, we are going to use a model predictive control approach, which uses this model again. And then the third time, as I explained to you, in the performance phase, where we can do a couple of reruns in order to validate the promised performance to the end customer. Good. There are a couple of simulation modes we support in the tool. I'm going quite quickly over them. You can do simple simulations, just standard control. This is typically very useful for baseline calculations. Typically, you have a heating system which just goes on off, doesn't do anything smart. That's one type of simulations we can do with the tool. We can run in full optimization mode. That means that we can calculate the maximum achievable value of all the smart devices in the simulation model. Typically, it's a pure optimization where you know perfectly well how all the data is going to evolve. It typically overestimates the value of what you can achieve, but it's still a very interesting one to have because it defines for you very well what's the upper bound of what you can achieve in your building. And then the third one, that's a pretty advanced one. We're still working on that one. I'm not going to try to explain this. Either you know what MPC is and this slide speaks for itself. If you don't know what MPC is, then you only have to remember that we do this in order to get a value out of the tool which is as realistic as possible of what we can achieve when we are actually going to implement it in the building. Then, as I told you before, we need thermal models. The thermal modeling is all a simplified RC models. I'm not going to talk too long about it. Just keep in mind we have two approaches. The first approach is that we, based on historical data, we have a gray box modeling tool which can fit these models onto the actual data. We are very aware that older buildings don't have a lot of data available, so we have an alternative path in place where we start from the building plans, from standard building stock information and so on to generate data for that gray box modeling toolbox. We have been using this already in other projects, so that's quite well, that works quite well. Good. Maybe all this was a bit boring and you want to get a better vibe of what we try to achieve with our tool. I hope I can come to that in our example bit. I'm going to start with a very simple example, and I am only focusing on the business case for one day, not so much because we can't do better than that, but because it makes it very tangible of what we actually do in the platform. We have a configuration, we are considering a house which has electricity, it has hot water. The heat pump makes sure we have the hot water, we have tap water consumption, and we have PV panels in our building. In that particular day, it's quite sunny winter day. Keep in mind our PV panels produce about 29 kilowatt hours of electricity during the day. We have a bunch of uncontrollable devices. They consume electricity a bit during the day. It gets a bit more from 4 or 5 o'clock onwards. As usual, we have space heating in our building. This is the reference simulation, so the heating system just switches on every now and then to keep the temperature in the house comfortable. In the afternoon, no heating needed because the sun is taking care of that, and then in the evening it switches on and off again a couple of times. Then we have a hot tap water boiler. There's not an awful lot of hot tap water used during that day, so it switches on at 3 quite random times during the day. And then we have an electric vehicle which is plugged in at some point in time. It's just charging till the battery is full. This is the reference or the baseline simulation where we don't do anything clever yet. And you see, of course, what happens is that we don't take advantage very well of the big PV consumption peak here. In practice, we see a lot of electricity consumption before it, after it, and in practice, we see out of our 30 kilowatt hours, only 10 kilowatt hours is consumed in the building itself, and 2/3 of it is injected in the grid. Now, why did I show this simple example is because you have to keep in mind that for all the simulations we do, it is data driven. So we are going to step by step calculate what is going to happen in the building based on historical data or based on forecasted data in the MPC approach. So we can do, of course, better. If we make that all smart, we make the boiler smart and the space heating smart, and we do smart charging on the car, you see, of course, what happens. The uncontrollable load and the PV stays the same. The space heating tries to buffer some heat in the building, in the building walls. It tries to push it to the maximum allowable temperature without violating constraints there. And the boiler starts charging at a smarter moment in time. The electric vehicle charging starts a bit later at a bit higher power in order to come to the perfect, of course I picked out a perfect day to show off what an optimization can do. Of course, no injection in the grid anymore. So that's in order to show how the tool actually works. Calculating all these time series, doing the control, doing the optimization, really on the time series. A more realistic example of what we can do with our tool is shown in the next example, where we have an example renovation of a family house. Again, we have electricity, we have gas before renovation, and we have hot water. The uncontrollable load, we have space heating, we have hot tap water, we have a buffer for the tap water. In first instance, the house is still heated by means of a gas boiler, and the setting is in such a way that we pay about 26 cents per kilowatt hour. Our residential price is 26 cents per kilowatt hour for electricity and about 5 cents per kilowatt hour for gas. So in the first run, before renovation, before we do anything smart, we can calculate on a year basis that the estimated gas cost is about 1,600 euro, electricity will be 960, in total 2,600 euro per year. Then we change our configuration, that is our reference configuration, where we do first an envelope renovation. So you see here, we insulated our building, we put insulation in the roof, we changed to double glass in the windows, of course with the same prices, where you see immediately the impact on the gas consumption, which drops quite a bit, which results in a first cost savings of 39%. So that's a first after renovation estimation of costs we will end up with. But we can go step by step, adding elements to our renovation. The second one is we are going to do electrification. We are going to add a heat pump and PV panels to our configuration. We stay with our insulated house. What you see happening now, important here is that we now assume that you can inject some excess electricity in the grid at a price of about 9 cents. That's rather high. In later simulations, we lowered that a bit to be a bit more realistic. What you see here is, due to this electrification in combination with PV panels, we can have a further cost saving of 28%. And the last step, and that's the one which is very relevant for our project, is we add the smart control. We add a smart controller which is going to optimize the behavior of the buffer tank here and the heating system in such a way that you make maximal use of your locally produced renewable electricity. What you see happening here is that you have a further drop of your electricity cost. So in the previous one, it was 1150, down now to 933 euro, or an extra 90% extra cost savings. Keeping in mind that that is for an investment which might be rather small. If you already have like a renovation with with modern new devices, adding that smart control does not have to cost an awful lot, but can give quite an additional savings at the end of the line. Okay, then the last example I have is how we use the tool to do some buffer dimensioning in a family house. It's kind of a very similar configuration, but with two temperatures in the house, one for tap water and one for the heating system in the house. And the question is, what's the best investment, to put a buffer tank on the high temperature collector or on the low temperature collector? So a couple of buffer sizes are checked here. Interesting, without smart control, you see this here. When you have no buffer, your reference cost is about 1,100 euro per year. And what you see is that when you add a buffer here, 100 liter, the cost only goes up. When you add a buffer for the space heating, the cost only goes up. And that's very obvious because you have no smart control on it. You have big tanks standing there, which are have losses and will lose energy. So that's obvious. Without smart control, that's not a very viable, interesting business case. When we add the smart control, however, you see that even without buffers, we drop from 1,100 to about 990 euro. There we only use the flexibility into the building mass, in the building building walls, in the heating system itself. You see further a drop when you add a hot water tank on the domestic hot water system of about 50 euro. And if you make the tank bigger, it does not really help an awful lot. You see that the impact when you add a space heating buffer, which works at lower temperature, is way less in this case. Just to give you an idea that our approach can help you in the sizing of appliances in a demand response context. I have two final remarks. I see that my time is nearly finished. Maybe something about the status of our platform. I told you it consists of quite a number of subtools. All subtools don't have the same status. So the Flex Model Creation subtool, the Energy Cost Cash Flow Estimation subtool, and the Financial Economic Calculation subtool are quite well on its way. We've proven the concept, and it's working pretty well. Configuration, yeah, it works, but it is still work for improvement. And the lower three here, the Guarantee Assessment subtool and the overall integration of the subtools, can still be better. Just to indicate you that we are developing a concept and everything is not fully in place yet, but we are definitely in place to show some first results. Last but not least, how do we proceed with this? The proof is in the eating. The proof of the pudding is in the eating. So we are going to test in two very different pilots. The first pilot case is in very modern office buildings of EDP in Portugal, and a second pilot in Belgium will be in a most probably in a school building in Belgium, which is built in the 6th stage, which urgently needs renovation. And so it is quite two different pilots, and it will be interesting to see how our approach will work in both cases. And that concludes my presentation, Annick.
Okay, thank you, Jef. Thank you for unrevealing some of the features of the ABEPM platform for us. I see that we have some questions in the chat, so I will go through them with you. The first one is on demand response and demand side flexibility. So the question is, if you are considering all decentralized energy resources in buildings, why are you just mentioning their demand response and not their demand side flexibility?
I'm not 100% sure that I understand the question very well. Definitely, we take in account local production. But if, for example, if the production is not local, but it is off-site, and you get the information when the energy is produced, we can definitely take that into account as well in the simulations as in the later control of the building. I'm not 100% sure that answers the question, but that's as far as I can get on it, basically.
Okay, so I would like to ask to the one that asked the question, if it's not the answer you expected, please come back to the chat to clarify what is your question then. There is another one which we know that demand response is still a concept that is little known and that not everybody trusts. It is looked at with distrust for multiple reasons by the end consumers. So do you think that the combination of EPC and demand response can help to make people more confident with and sensitive to energy issues, understanding the role of demand flexibility in a sustainable energy transition?
I think we are, of course, a selected audience and in this webinar, and I think a lot of people are convinced that the demand response can contribute an awful lot in further reduction of emissions. But indeed, the person asking the question is right. It is not always easy to explain that to people which are not so familiar with how the whole electricity system works. That's one of the reasons why I believe that you have to go for a automated approach. It can't be the case that you have too many interactions with the outside world. Can you please do this? Can you please do that? It should go in a quite automated way. And what people always appreciate is that if you do something and you can reduce the operational costs for them, they like it, whatever it supports. So I think from that point of view, the fact that we can try to make promises beforehand of how much savings you can achieve, that we have something in place where we can validate that we really did that, and they don't have to bother about it too much in the meantime, I think this can only help to convince people to take that step.
Okay, so you mentioned the automated approach. I think this is somehow related perhaps to the next question. So we have somebody from the audience saying that, okay, you talk about wash machines and fridges, which are controllable loads. So why do you consider them uncontrollable?
Yeah. That was maybe not the best example. What I just reused some icons and I put indeed there a washing machine and a dishwasher, and there were maybe bad examples because if there are some white good appliances in households which are controllable, then it are these two. So a very good observation from somebody in the audience. What I really mean there is the lighting, the background consumption of your computers, of your TV. You don't want you want to, all these background devices which are there in your house or in bigger buildings. I took icons for residential, but of course we are focused on bigger buildings as well. Absolutely right.
So well noticed then. Then there is a question on the examples that you gave at the end. So your examples of cost savings, are they only based on energy prices, so euro per kilowatt hours, or also taking into account grid costs, taxes, and other?
Yeah, the examples I have given are all in a Belgian context. So all the costs are taken into account, but of course you pay if you have a smart meter, you pay for quite a bunch of taxes and grid costs, which you can avoid if you use the electricity directly from your PV, and that's a big part of where the money is made in these optimizations. So we definitely take them into account. Yes.
Okay, then there is a question about the optimization models that you're using. So what kind of optimization models are you using? Are they purely mathematical, or are there also assumptions on historical data, or do you use machine learning? So what is behind
that's a good question. Since we are going to work with model predictive control, we definitely work with models. So in the optimizations, we definitely use simplified models We try to use, if possible, we try to go to linearized models because they're a bit easier to optimize. So it is definitely a model-driven approach. On the other hand, you have seen in one of the slides, I went quite quickly over that in our MPC approach, for the data which comes in, we are going to machine learning kind of approach to do forecasting of the non-controllable data which we are having to cope with. So it's a bit of a mixture of yes, the models are the model itself is model-based, but the data, we use some machine learning techniques there to forecast what is going to happen in the next, let's say, 24, 48 hours.
Okay. Yeah, I think we will have one more question. I see that people are submitting many questions, but we will just do this last one and try to answer the other ones by other means then. So in the examples that you've shown, the heat pump smart control was used to maximize the self-consumption from PV. So are there scenarios in which services are provided to the network, like congestion management or market arbitrage also modeled? And if you do so, how is the regulatory environment and the remuneration of services considered? So it's a long question.
Very good question, and the answer is pretty short. We did not. So in this particular example, I already indicated in the middle of my presentation, more or less, we have quite focused at this right moment on indirect demand response control schemes. So what you are referring to, where the person who asked the question is referring to, is rather the interaction with a grid request or a request from an aggregator and so on, which we did not incorporate in these examples. So it's really incentive driven based on how the electricity contracts are set up for the customer at in these particular examples. I hope that answers the question.
Yeah, I see that there are still questions coming in, but we have to stop this session. So we will try to answer them afterwards. I have to check with the organizers how we can cope with that. So I would like to conclude this session then by perhaps just briefly summarizing some of the things that we have learned today. So developing the active building EPC and incorporating demand response in EPC businesses faces various barriers, as Nilufar mentioned. And to extend the classical EPC to active building EPC, we mainly highlight by adding active measures to the contractual terms and giving a dedicated focus to performance-based attributes. And of course, the extension affects the business relations and interactions of EPC stakeholders by introducing demand response schemes, and therefore its uptake requires according modifications in regulations and guidelines. From Jef, you have learned that ABPM is a generic business case calculation tool, which includes the operational cost savings in demand response schemes. The building blocks are being used and reused in all phases, so contracting phase, operational phase, and performance phase. And ABPM should help reassuring ESCOs and customers on understanding the value and the impact of the various demand response schemes. So with this, I would like to thank the speakers for their excellent presentations. I want to thank the audience for the many questions and for participating and your interest in our session. And of course, I want to thank the organizers for giving us the floor here at this very last FLEXCON track. And now I give the floor to the leaders of FLAN and Smart EM.
Yeah, thank you very much. I'm Bertrand Auden. I'm the chairman of Flexible Power Alliance Network. This is the last session of a series of the FLEXCON afternoons, online sessions this year. Before I close down the conference and give the word to Frauke, some words about what we've learned and the things to come. In this conference, I think we've learned that flexibility really takes off in a practical manner. Allow me to mention some things that we will do in the coming months and the next half year. There is the Senelec Flex protocol, the so-called S2, which is going on for consultation, and we are preparing for implementation. That is the protocol between the house management installation and the flexible appliances in the house or the building. It's very important that we go on with that. Then there is in the Netherlands a Dutch climate agreement where we work on also where there is a guideline that we have to work on open standards for PV panels and heat pumps, for instance, very important, and we work on that together with the associations of energy companies and electrotechnical installations. And further on, we will be involved in the innovation programs and the Dutch urban energy program, flex potential reports, for instance, from TenneT, discussions on grid incentives, and we are also in real-time interfacing. This comes as a consequence from EU guidelines, for instance, the DCC and the RFG, the requirements for generators and the demand connection code. If you want to be involved, approach us, become a member, because it will be very tough for us to do this, and we need more participants to support us. And you see the email below of me, but you can also, of course, approach Adriaan. And that being said, I would almost forget the most important action of all. That is, we will be organizing together with SmartN a next FLEXCON. First of all, I want to thank wholeheartedly the organizers for this FLEXCON. It was a huge challenge. Also given the special situation this year, but you have done it in a wonderful way. So thank you, Alicia Medina, Michael Villa from SmartN, and Adriaan van Eck on behalf of Flexible Power Alliance. You've done a great job in a very extraordinary circumstance. And now I give the word to Frauke Thies from SmartN, who will have some famous words on it was wonderful also to work with you. We have a structural agreement, and once more, it has delivered on its promise, like you always do, Frauke. So please take the floor.
Thank you very much, Barrett. And yeah, I think we are already behind time, so I'm not going to spend a lot of time to mirror the very important invitation that Barrett has expressed on the work that FAN is doing. Of course, likewise, I invite you all to have a look at the work that SmartN is doing and join our activities. So don't hesitate to have a quick look at our website. But now, most importantly, before we close, I want to express a number of thank yous, picking up on Barrett's very important final words to thank the team. I also want to thank, very crucially, our sponsors, with whom this whole event would not have been possible, and who actually stood by us and were flexible also when we had to change and shift the event entirely from the planned sessions in Amsterdam to the online approach. I also want to thank our excellent speakers, really, who filled the event with really high quality input as always. That was both cutting edge, but also not shying away from challenging questions and from technical details. So big thanks to all of you throughout the 6 sessions. And then I want to thank all of you, our audience, who really made sure, to our big surprise and our big satisfaction, that the online format even remained very interactive and engaged, keeping up the spirit of the previous editions of FLEXCON. So thank you very much for keeping it active, keeping it interactive. Thanks for all your good questions. And then finally, even though Bert mentioned it already, I think I have to repeat a big thanks to all the organizers. Thank you to our partners, FAN. Thank you, Adrian van Eck from FAN. And thanks to Mikael Villa, Alicia Medina, and Usulela Soya from the Smartin team. You really, as Bert already outlined, you kept the high spirit, remained high-spirited, even despite all the adversities, making FLEXCON 2020 happen. And on that note, thanks again to all of you, and I hope to see you in person again in 2021. Thank you all.
Bye-bye.